So last day we looked at the expansion and compression factors that are in the denominators with the x and y. So the expansion factor with the x is in the denominators a, the expansion factor for y is in the denominator as b. And now we're going to look at the shifts. So if we have an x minus h, that's a horizontal shift of plus h. Now what's changing from with regular functions, and this is not a function, it's a relation. What's changing from regular functions is now that the y translation is with the y variable, the minus k represents a shift of plus k. Okay, so we are now how we observed and interpreted the translations and expansion and compression for x's. We're going to do the same for y's now, since in the relationship the y variables are the y transformations are with the y, just like with the x's in functions. So our center is going to be at hk, and the length of the x-axis is going to be double the expansion factor, or 2a, and the y-axis length is double the expansion factor b. And the centers, the vertices, since the center is going to be at hk, if it is trans x, the y-coordinate of the vertex is the same as the center, and the x-coordinate of the vertices are just going to be starting at the center. We're going to go to the right, the horizontal radius essentially, and left the horizontal radius from the center. The same thing can be said for along the y-axis. The horizontal center is going to be the same, okay, and then the vertex moves from k up b and down b, okay, and then we end up with our trans x and trans y hyperbolas. So if we were to look at it like this, I'll just sketch it out. Okay, we have our center. Okay, their center is going to, let's say our center is randomly going to put it there. It's going to be h and k. Okay, if it's trans x, we're going to go h plus a to get to the vertex here, and then h minus a to get to the vertex here. Okay, so we're starting at h, we're going to the right and left, and we're going to locate our vertex to be able to draw in our hyperbola like that. Okay, now if it was trans y, the trans y situation is similar. It's going to look like this. We're going to have our, we can put our vertex here at hk. Okay, and since that length is going to be b, we're going to go from k plus b, and then we're going to go k minus b. Okay, so that length is b as well. And that would locate our vertices for trans y, and then we can just draw our vertices through there like that. Okay, and then the h coordinate would stay the same for that vertex coordinate because it's not been translated from there. Let me just clean this picture up a little bit. Okay. That coordinate here is going to be the center, which is h comma k. Okay, so we're going to go plus b minus b from that center k value. Now with ellipse, it's exactly the same thing, except really there's not much difference between ellipse and hyperbolas, other than once we locate the vertex vertically and then the expansion horizontally, okay, we draw outward, whereas ellipse we're just going to draw inward, right? We draw that elliptical shape, and the x-axis length is going to be 2a, the y-axis length is 2b, similar to what's going on here. Okay, so let's try a few of these hyperbolas. So we want to first of all put this into the graphing form. It makes it much easier to deal with. So I'm going to divide both sides by 36. So I end up with 9 over 36. This simplifies to 1 over 4. This becomes 4 over 36. which simplifies to 1 over 9. That's equal to 1. So right now we need to identify one more thing compared to last day. We need to identify the center. Okay, so I'm going to make sure we're clear on what the center is. We'll do this in green. Okay. So the center coordinate is going to be based on those shifts. So the center is going to be at x equals -3, y equals 1. So I'm going to start sketching my diagram over here. X is -3, y is 1. Okay, so there's my center. I also want to know my a and b values so I can work out my slope. Okay, so a is equal to 2 coming from here, and b is equal to 3. So then my slope is going to be equal to 3 over 2. Okay, so rise over run. So I want to also use these points to locate my vertices. So these are not just a ratio, these are the actual a and b values. So my a value being 2, I'm going to move 2 to the right from the center, so 1, 2. Okay, so that coordinate is going to be at -1, +1, and it's going to move 2 to the left here. So this coordinate is going to be -5, +1. Okay, so those are my x-axis vertices. And then my y-axis vertices, I'm going to go up 3. 1, 2, 3. So that's going to be at -3, +4. Okay, and it's going to go down to about here. So it's going to be -3, -2. It's going to be that coordinate. So then these coordinates are what I use. Now if this was a ellipse, I can just draw my ellipse in. But now I'm going to draw in my slopes. Okay, so I'm going to locate those corners. And those corners allow me to draw in my slopes, like this. Okay, so the slope of this line is y equals 3 over 2. And we might as well write the equation of that line, because we do know the center is at -3, +1. Okay, in fact, I'm going to write down the equation of this line. Y equals -3 over 2, x plus 3, or x minus -3, plus 1. So -3, +1 being the center is a coordinate on this line, so we can write that in the point slope form. So this is a trans x graph. So the last thing I really need to do is just sketch my graph in. Since it's trans x, I'm going to use the x-axis here. Draw that in. Draw that in. Again, the vertex and the asymptotes allow me to sketch that graph.